So here's a good use of some complex numbers. Use the fact that x equals 2i is a root of this polynomial to find all of them. Since this is to the fourth, we're actually looking for 4 roots in total. Well, with this one, I know that there's 2 ways to look at it. I know that if 2i is a root, then its complex conjugate, negative 2i, also has to be a root. That means that if I move this to the left-hand side, x minus 2i was set equal to 0. Or, with this one, x plus 2i was set equal to 0. So I'm basically working backwards from a factoring problem. And that means that just before those were set equal to 0, it was factored like this, and had been set equal to 0. And then I can use FOIL to multiply these out. There's going to be x squared. The middle terms are going to cancel. There's negative 2ix and positive 2ix. And then there's the last term times the last term, negative 4i squared. And so that means that, well, negative I squared is negative 1. Together with this is going to be that x squared plus 4 was a factor of the original polynomial. If you don't feel like doing all of this, the alternate is you start with that first fact that x equals 2i and then square both sides. So we've got x squared, and then there's going to be a 4 and an I squared, which makes negative 4. And move this to the other side, x squared plus 4 needs to be a factor. So you can either do it this way or this way. You end up with x squared plus 4 has to be a factor. Then, if it has to be a factor of that polynomial, we can use long division to divide x squared plus 4 into this fourth degree polynomial, x to the 4th minus 3x to the 3. There's 9x squared minus 12x plus 20. So I need to start with an x squared, because that way x squared times x squared is going to be x to the 4th, and when I subtract, those will cancel. But I have to distribute this times this is going to be 4x squared. Don't line it up with the x cubes, line it up with the x squares. 4x squared. And then subtract. And we need to subtract this second line. So there's going to be x to the 4th minus x to the 4th. As far as the x cubes, just carry this down. And then there's 9x squared minus 4x squared for a 5x squared. And then repeat. In order to get this to change into that, I need a negative 3x. And then distribute negative 3x times this is negative 3x squared. And then a negative 12x. Wait a minute. This times this is cubed. And this times this is not a squared term. So I should not line it up there, but I should line it up right here. So this is going to be negative 12x. And then subtract this line. These are going to cancel. 5x squared has nothing to combine with, so it stays there. And then we've got, well, this together with this is a positive 12x, but when we carry down this negative 12x, they're going to cancel. And then carry down this positive 20. Now if I did this work over here correctly, then this thing should divide into this big polynomial evenly, so I should have a remainder of 0 coming up. Let's see, next I need to use a 5. So plus 5 is going to be 5x squared, and then 5 times 4 is 20. And sure enough, when you subtract those, the remainder is 0. So it divided evenly. But we're not done yet. Now we've got a quadratic, so there's 2 more answers that we get from the quadratic formula. So once all of that's done over there, now use the quadratic formula. So we've got x squared minus 3x plus 5 is equal to 0. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And then it's all divided by 2 times a. So it's going to be 3 plus or minus, and then in here we've got 9 minus 20, which is negative 11. And so in total, we've got 4 solutions. This one, 2 complex numbers, and then it looks like we're getting 2 more complex numbers. X is equal to 3 plus or minus an I radical 11 divided by 2. So finally my answers are plus or minus 2i and 3 plus or minus I radical 11 over 2.